Good morning, everyone, and welcome to the second session on pollination biology and plant physiology. We have some very interesting talks lined up for you in this session, so we're looking forward to it. So just a few reminders, you can put your questions in the Q&A section for any of our speakers, and you can also upvote those questions to, if there's a question that you're particularly interested in and you would like to know the answer to. We have two speakers in our session. Unfortunately, our last speaker is unable to join us today. So we will start off with, we will have two presentations today. Speakers, just a reminder that you have 20 minutes and at 17 minutes, I will remind you when you have 3 minutes left to go. All right, so we'll start off with our first speaker for the session. We have Jessica Minnar presenting on the key pollinators of the summer flowering Alaraceae. Jessica, you're welcome to take it away.
Okay. Good morning, everyone. As Steph said, I'll be presenting part of my master's research, which will be called Birds or Bees for Fruit and Seeds, Key Pollinators of the Summer Flowering Alaraceae variation Raceae. Many South African aloes flower in winter, serving as a major food source for birds as they produce high quantities of nectar. Birds, both generalist and specialist nectarivores, therefore play a key role in the pollination system of aloes, many of which have floral traits consistent of the bird pollination syndrome. However, some of these traits, such as its copious nectar production and abundance of pollen, also makes aloes attractive to insects, especially bees. Therefore, despite having many traits characteristic of the ornithophilus pollination syndrome, birds and bees play various roles in the pollination system. Alaraceae variation Raceae is a summer flowering aloe endemic to South Africa and is mainly distributed in Mpumalanga. Similar to most South African aloes, Alaraceae has floral traits consistent with the bird pollination syndrome, as seen by their red-orange tubular perianths and its copious nectar production. In previous studies, both birds and bees have been observed as frequent visitors, but their role in the pollination of Alaraceae has not been formally investigated. Additionally, generalist and specialist nectarivores were observed visiting frequently, but it is unclear whether Alaraceae has a generalist or a specialist bird pollination system. During studies of the 2014 and 2017 flowering seasons by Craig Symes and Stephanie Payne respectively, different patterns of visitation rates between birds were observed, and each study yielded contrasting nectar properties. Therefore, we aim to investigate the role of birds and insects, particularly bees, in the reproductive biology of Alaraceae and the relative importance of generalist and specialist birds in its pollination. The pollinator effectiveness of birds and bees in Alaraceae was investigated by comparing the visitation rates of specialist and generalist nectar-feeding birds and comparing the pollen loads of birds and insects. We also used pollinator exclusion experiments to determine the role of bees in the pollination of Alaraceae. Observations of floral visitors were conducted to identify the main floral visitors and the visitation rates. Camera traps were set up over the 3-week study period and left to run for 24 hours, and incidental observations were conducted for approximately 5 hours per day over the study period. To determine whether insects were just visitors or pollinators, insects visiting Alaraceae flowers were caught and swabbed for pollen. Birds were caught by a licensed bird ringer, and the throat, beak, crown, and foot of the birds were swabbed for pollen to determine the main sites of pollen deposition. Pollinator exclusion experiments were used to determine the relative contributions of birds and bees to the pollination and reproduction of Alaraceae. Individual racines on 24 aloes were randomly assigned to either open treatments, which only allowed access to all visitors, bird exclusion treatments in which only insect visitors were allowed, and total exclusion treatments in which no visitors were allowed. We then calculated fruit set and seed set and compared them among treatments. So, approximately 30 invertebrate species were observed visiting flowers of Alaritii, and these included bees and solitary bees such as Eulacia glossum species, flies, various grasshopper species. However, honeybees contributed approximately 85% of all insect visitors to Alaritii, and they were observed drinking nectar and removing pollen. Solitary bees were also frequent visitors and were observed drinking nectar. Moths were frequent nocturnal visitors, but their role in the pollination of Alaritii still needs to be investigated. 10 bird species, which included 7 generalist and 3 specialist birds, were observed visiting Alaritii. And these included Cape weavers, malachite sunbirds, amethysts, Cape longclaws, common fiscals, to name a few. However, only Cape weavers, malachite sunbirds, amethyst sunbirds, and greater double-collared sunbirds were observed feeding on Alaritii flowers. The Cape weaver was the most common generalist and overall bird visitors, accounting for almost 58% of all bird visits, while the malachite sunbird was the most common specialist visitor, and it accounted for 33% of all bird visits. And this is consistent with SAAB's findings during the 2014 flowering period. But even during the 2017 flowering period, Cape weavers still contributed 41% of overall visits. The Cape weavers have therefore been consistently abundant during multiple flowering periods, whereas the abundance of malachite sunbirds has fluctuated. However, since malachite sunbirds are consistently abundant at this population of Alaritii each year, their fluctuating abundance suggests that there may be shoppers at Alaritii within the tourist pattern. So, what this means is malachite sunbirds are known to be shoppers, and they increase in abundance according to nectar or food availability. And within their tourist behavior, so they would visit, for example, Leonotus leonoris in summer, Protea caffra in autumn, and aloes in winter. But we still need to investigate the species richness of birds visiting Alaritii to determine whether this fluctuating abundance can be attributed to changing food or nectar availability in this region. High pollen loads were observed on both birds and bees, and this did not differ significantly, suggesting that both birds and bees play a key role in the pollination of Alaritii. For the birds, pollen was present on Cape weavers, malachite sunbirds, and greater double-collared sunbirds, but only one greater double-collared sunbird was caught in the mist nets, and it had a lower pollen load compared to the weavers and the malachite sunbirds, and they were not abundant or frequent visitors to Alaritii. Unfortunately, we did not catch any amethyst sunbirds, so we could not determine whether they carried Alaritii pollen or not. Total pollen load did not differ significantly between Cape weavers and malachite sunbirds, and their high pollen loads, coupled with their frequent visitation and high abundance, suggest that both birds are both effective pollinators of Alaritii. And although bees and solitary bees had comparable pollen loads to birds, they did not greatly contribute to the reproductive output of Alaritii, as shown by the pollinator exclusion experiments. So bird excluded plants had significantly lower seed set compared to plants that included all pollinators. Bees are shown to play a negligible role in the pollination of many ornithophilous aloes, especially those that have strongly exerted filaments, as it prevents the bees from entering the floral tubes and successfully transferring pollen. But bees in this case are still effectively transferring pollen, as seen by the fruit sets, as they still produce fruit. But they only play a minor role, as they are likely transferring south pollen, which would explain the reduced fecundity in the bird exclusion treatments. The relative importance of generalist and specialist birds as pollinators of Allaricea was determined by investigating the pollen load and main pollen deposition sites, the nectar properties, and comparing their visitation rates. Nectar volume and concentration was measured across 11 aloes to determine whether properties of Allaricea fall within a generalist or a specialist bird pollination syndrome. To determine whether generalist or specialist nectarivore birds could have contact with stigmas of the flowereters visited, their bill morphology was compared to the floral morphology of Allaricea. We measured bill length, and this was measured from the union of the bill at the base of the skull to the tip of the bill, and this was compared to peri and tube length to determine whether the bills can fit into the flower. The curvature of the culmen of the beaks was measured and compared to corolla curvature to determine whether flowers may be penetrated by malachite sunbird and Cape weaver beaks. Stamen and style length was also measured to determine whether the bills and other sites of pollen deposition came into contact with the reproductive organs of Allaricea flowers. Allaricea pollen was mainly deposited on the throats of both Cape weavers and malachite sunbirds, where they would come into contact with the reproductive organs of Allaricea as they fed on the nectar. This seems to be a common pattern observed in aloes with strongly exerted filaments. And although the throat was the main site of pollen deposition, high pollen loads were also observed on the crowns and the bills of each species, and this did not differ significantly between Cape weaver and malachite sunbirds. As shown by the arrows, the orange Allaricea pollen can clearly be seen on their throats, their crowns, and their bills. Allaricea produces large nectar volumes, which was lowest at 7 o'clock and measured around 88 microliters, and it peaked at o'clock measuring 140 microliters. Compared to nectar volume, the nectar concentration was more consistent throughout the day and measured about 12%. And these nectar properties indicate that Allaricea has a generalist pollination system. So Allaricea has long, narrow perianth tubes with strongly exerted stamens and styles. And when combined with its generalist nectar properties, it indicates that Allaricea has intermediate floral traits between a generalist and a specialist bird pollination system. And these traits enable effective pollination by both Cape weavers and malachite sunbirds. If we compare the morphology and the feeding behaviors of these two main pollinators, we can see that the Cape weavers feed on the aloe nectar by perching on the raceme peduncle and feeding on the basal flowers by fully inserting their heads into the flower. They also feed upside down by perching on closed flowers on the raceme. As they fully insert their heads into the Allaricea flowers, it results in large pollen loads being deposited on their throats and crown as they rub against the filaments. Therefore, key facial regions come into contact with the reproductive parts of the flowers, and this enables cross-pollen transfer in Allaricea as they move from plant to plant. Therefore, when defining a primary pollinator, we should also take into account feeding behavior and not solely the floral morphology and the bill morphology. In comparison to the Cape weavers, malachite sunbirds stretch their necks to feed on the long floral tubes, and they often extend their tongue to do so. Their feeding is made easier by the curved perianths of the allarite flowers, and these match the decurved bills of the malachite sunbirds, and this enables them to feed efficiently without having to manipulate the flowers through their perching position. So the malachite sunbirds perch on the peduncle below the inflorescence and feed on the basal flowers by reaching their heads upwards, and they come into contact with the strongly exerted filaments, which enable pollen deposition and cross-pollen transfer as they move from plant to plant. Thus, in conclusion, Allaricea is predominantly bird-pollinated, which is consistent with its ornithophilous floral trait. Although highly abundant, honeybees only play a minor role in the pollination of Allaricea. The long flower tubes and generalist nectar properties enable effective pollination by both generalist and specialist nectarivores. Birds and malachite sunbirds are both effective pollinators of Allaricea, but due to their higher abundance and more frequent visitation, Cape weavers are concluded to be the primary pollinator of Allaricea. And the fluctuating abundance of malachite sunbirds at this Allaricea population suggests that they may be shoppers and only increase in abundance according to the nectar availability. Okay. Thank you.
All right, thank you, Jessica. That was a great presentation. We have a few questions here for you. The first one is from Glynis. How did you measure beak curvature?
So when we were in the field, we took pictures of the birds, and I used ImageJ to measure the curvature of the beaks. And then this was compared to the perianth curvature, which was also measured in ImageJ.
All right, great. And then another question here from Anonymous. Could it be possible that the Cape weavers were rather hunting insects than searching for nectar?
I don't think so, mainly because in lots of the camera trap footage and when I was doing the observations, you could clearly see the Cape weavers fully inserting their heads to drink nectar. And their visits usually correlated with the nectar production as well. So they would mainly feed in the mornings and in the evenings. So I do think that they were mainly feeding on the nectar.
And then another question from Sam. Could the nectar robbers then pollinators?
Well, I do think that, okay, so the aloes filaments were very strongly exerted out of the floral tube. So as they would feed on the nectar, which was quite dilute, so it would be present on the filaments, and they would just move around the filaments. So I think that's where they picked up the pollen as well as they moved from flower to flower. They also had the pollen bags. I forgot the name, but yeah, so those were present on all the bees, while most of them that I saw had pollen on them.
All right. Okay, then another question for you from Shirk. Did you try and do single species visits, i.e. only weavers and only malachites, and then determine seed set after these visits?
Oh no, so we didn't do single visits. We did separately analyze the visitation rate of the two bird species, but we didn't do separate visits and then determine the seed set to determine which bird is playing a higher role in the pollination. Would be interesting to see though, if they are both effectively causing the plant to set more seed or not. Yeah, so definitely an option for future research. Yeah.
Great. And then from Lauren, what time of year does Allaricea flower?
Oh, so they flower around February to March. So and this is well, not common because most aloes flower in winter. So yeah, they flower in Feb to March.
Yeah, so majority of your bird pollinated aloes flower in winter.
Yes.
This is why this one's a bit unusual.
Yes.
All right, great. Do we have any further questions for Jessica? Otherwise, we're going to move on. All right, great. Thank you so much, Jessica. It was very interesting.
You.
Thank you. So currently, our next speaker does not appear to be in the room. Monkwali, are you here? We can't see you on the list. You'll just let us know if you may be here under a different name. Okay. Doesn't look like you're here. So then and our last speaker is also not joining us for the day. So then that looks like the end of our speakers that we have planned for this session. So well done, Jessica. Thank you for presenting for us. And thank you to everyone for attending this session as well. It's a very short session, but still a very interesting one nonetheless. The ecology session is still running. There are another 4 or 5 talks happening in that parallel session. So I recommend that you switch to that session and go watch those presentations. So once again, thank you to everyone for attending, and thank you to Jessica for presenting as well. Thanks. Have a good morning. Enjoy the rest of the conference. Thank you.